Hi class, welcome to lesson 61, our first lesson in unit 11, organic chemistry. In this lesson, you are going to be able to identify the properties of organic compounds, identify hydrocarbons based on their formula, and name hydrocarbons using reference tables P and Q. You can take your own notes or use guided notes, but let's get started. Organic compounds are special compounds all centered around the element carbon. Now, not every compound that contains carbon is organic. Organic compounds require both carbon and hydrogen. So when we think of some of the compounds that contain carbon that we've used earlier this year, like carbon dioxide, that is not organic because it does not have carbon and hydrogen. Or something like sodium carbonate, again, is not organic because it doesn't have hydrogen. Now, there are a wide variety of organic compounds all around us. And here are some examples like petroleum and coal and wood, plants and animals. So these are compounds that are found in living things or things that are been produced by living things. So you should be asking, why carbon? Well, carbon is really special because carbon has 4 valence electrons, meaning that it can form 4 bonds. This allows carbon a really special opportunity to concatenate, or to catenation means that carbon can form bonds with itself, and these can be bonds in chains or rings. So there's a wide variety of carbon structures due to this ability to form 4 bonds. So it's important that we know the properties of organic compounds. Since organic compounds contain carbon and hydrogen, organic compounds are covalent compounds. So the properties of organic compounds are also typically the properties of covalent compounds. Organic compounds tend to be nonpolar, which means that they are insoluble in polar water, and they are soluble in nonpolar substances. This is important because our cells are made up of organic compounds, and when we take a shower, we don't want to disappear or dissolve away. Organic compounds, like most of their covalent compounds, are non-conductors of electricity because they don't have free-moving ions. Now, this is the exception if you have an organic acid like acetic acid found on reference table K. Most organic compounds, like most covalent compounds, have really low melting and boiling points because they have weak intermolecular forces of attraction. So the bond that holds the molecules together is strong, but the attraction that holds one molecule to the next molecule is relatively weak. This allows organic compounds to be gases and liquids. And some of them are also solids, but many gases and liquids will exist. Now, one observation we have for organic compounds that we have for all things is that as we increase the size of an organic compound, so if you look here to this chart, you can see as the number of carbons and hydrogens increase, so does the boiling point because the intermolecular forces are able to increase here. Many organic compounds are also combustible or flammable. So this is a chemical property of the substance. And the reactions that organic molecules undergo tend to be much slower than inorganic compounds because they have those strong intramolecular forces that hold them together. So they resist breaking bonds in order to make new ones. So by now, you should be able to identify the major properties of organic compounds in comparison to inorganic compounds or compounds that do not contain both carbon and hydrogen. Now, hydrocarbons are a special class of organic compounds that contain only carbon and hydrogen, as you can pretty much tell from their name. Now, the homologous series are a group of hydrocarbons that have similar properties and similar structures. And we are going to use reference table Q to help us name these various compounds. So here you can see on reference table Q, there are 3 different categories within the hydrocarbon series. We have alkanes, which have single bonds between the carbons. We have alkenes, which have at least one double bond between carbons. And we have alkynes, the Y is an I, just like Lytle, where we have at least one triple bond between the carbons. And we're given a sample structure and a sample name and a general formula for each of these families in the homologous series. Now, reference table P will help us name structures in the homologous series because they give us the prefix that we're going to use to indicate the number of carbon atoms. So here you can see in all of these structures, in the first compound, C2H6, 2 carbons means its prefix will be F. Or in the next structure, C3H6, its prefix will be prop. 4 carbons is bute, 5 carbons is pent, and now we're going to use the same prefixes we use in geometry. So 6 carbons is hex, 7 hept, 8 oct, and 9 non. Now, we can put reference table P and Q together to get a hydrocarbon name. So in this first example, you can see that I have 1 carbon, so the prefix is meth. And in the next example, I have 2 carbons, so the prefix is F. Now when I look at reference table Q, I can find the suffix. So in the first structure, there is only a single bond with the carbon, and so that is going to be an alkane, so it will end in ane. So that is called methane. And in the next structure, we have a double bond between the carbons. So the double bonded structure is an alkene, it ends in ene, so that is ethene. So let's see if we can put these 2 together. So in the first structure, there are 2 carbons, so the prefix is F. And in the second structure, there are 4 carbons, so the prefix should be bute. In the first structure, there's a triple bond. So we're going to look at reference table Q, and we can see that triple bonds are alkynes. They end with the suffix Y-N-E. So this is called ethyne. And in the structure with 4 carbons, all of the carbons have single bonds. So the single bond suffix is ane. This is butane. So by now, you should be able to identify hydrocarbons based on their formula and name hydrocarbons using reference tables P and Q. One more detail that is given about hydrocarbons on reference table Q is the general formula. You can see that the general formula has this variable N, and we know that alkanes have 2N plus 2 hydrogens for every carbon, alkenes simply have double the hydrogen, and alkynes have 2n minus 2 hydrogens. So as a general rule, if you have double the hydrogen, you're an alkene. If you have more than double, you're an alkane. And if you have less than double, you're an alkyne. So when we look at this general formula, we have C5, so that's pent. And then we have 12 is double plus 2. So this is an alkane, so this is called pentane. So here, let's do a couple examples together. So in the first example, we have 2 carbons, that's F. The second example would be pent. The third will be prop, and the fourth will be but. Now, when we look at the first example and we apply the formula from reference table Q, 6 is more than double 2, so that's an alkane, so that's ethane. When we look at the next example, 12 is more than double of 5, so that is another alkane, so that's pentane. But 6 is exactly double 3, so that's an alkene, so this is called propene. And 6 is less than double of 4, so that's an alkyne, so this is called butyne. So by now, you should be able to name a hydrocarbon using reference table P and Q. And that is the last skill that you need to have mastered for lesson number 61. Make sure you've taken great notes. Write down any questions you have and we'll discuss them in class, and I'll see you soon.